Hi, so today we're going to talk about the Solow model of economic growth. This is going to be sort of a really simple overview of, uh, of of the model. This will give you just kind of a feel for what it has to say and what the inputs into this economic model are. This model was written about by Robert Solow and another economist named Swan, and it's since then uh, been developed a lot, but it's the foundations of it are still really important to the study of macroeconomics. So the most important thing to understand is the idea of a production function in which you've got output or GDP is equal to the technology level A times a function of the capital stock, the total capital stock, and the total labor force of the economy. There's no government expenditures in or taxation in the Solow model, and so that doesn't figure in. And the countries in the Solow model are in a state of autarky, so they don't trade with one another. Um, so uh, one example of the production function could be the Cobb-Douglas production function. That's one that's often looked at, and you might be familiar with that from some of your other economics classes. Um, and that's the one that's very frequently used. But we won't go into we, it doesn't really matter for this video whether it's a Cobb-Douglas production function or a different production function. So importantly, we look at output per worker, um, which is little l, and capital per worker, lowercase k. Uh, putting it in per capita terms gives us a more realistic idea about the health and growth of the economy is in just in terms of absolute terms. So just uh, and another important thing to this Solow model is that we assume constant returns to scale. And if you assume constant returns to scale and you divide this production function up here, you divide K and L by L, then because there's constant returns to scale, we can divide Y by L, and we will get then this function down here where output per worker is equal to the technology level times a function of capital per worker. Because when we divide by 1, the L becomes simply 1. Or when we divide all these terms by L, this becomes 1, this becomes capital per worker, and this, because of constant returns to scale, becomes output per worker. So there are a few pretty important equations here to understand, or concepts really, which is that real savings is equal to real investment is equal to the change in the total capital stock of an economy. So net investment can be thought of here as the total level of investment in an economy minus the depreciation rate delta times the total level of capital stock in the economy. So your investment, this I, is sort of being offset by the depreciation of capital. You think of your machines breaking down, needing repair, your buildings falling into disrepair and needing maybe to be torn down, or anyways, just your average depreciation of capital. That's sort of offsetting your new investment or your investment. So net investment is the total investment minus depreciation of capital. And we can think of that as equal to the change in capital. And at the same time, we think of that as equal to real savings of an economy. The savings rate of an economy is how much the economy saves. In the Solow model, we assume that that all the output of an economy is either saved or consumed, and um, and the real income here is the total GDP or total output Y minus the depreciation, minus total depreciation. So that's our income, and the real saving is the amount of that we save. So we've got S times income is equal to our real saving. So these are all equal, and that's really important towards sort of deriving the real key equation of the Solow model. It's also important that delta L, the change in the labor force, divided by the total labor force is the population growth rate, which we denote by N. And the change in the growth rate of the capital stock here in the third line, we can just find that by taking the real saving equation, S times output minus depreciation, and dividing all of that by total capital stock, and these two K's cancel out, and we just get the growth rate of total capital stock is equal to the savings rate times Y divided by K, which is the average output of capital minus depreciation. Another really important equation here is going to be that the growth rate of capital per worker is equal to the growth rate of capital minus the growth rate of labor. So we can take this, and we know the growth rate of capital is just equal to the savings rate times average output of capital minus depreciation. And we can substitute that into here. Delta L divided by L is just the population growth rate. And so we get this here, the key equation of the Solow model, which is that the growth rate of capital per worker is equal to the savings rate times the average product of capital minus savings rate times depreciation minus the population growth. Okay, so let's talk about the steady state of capital, which is an important concept here. It's denoted by K star, and this is when depreciation is equal to investment. So I'll show this graphically. What we've got here is the blue curve, which is really our production function, kind of, and the investment curve, I is equal to the savings rate times a function of capital per worker. Depreciation is a linear function, and it's our green function, or our green line here, grows at a constant rate. So at any point before K star here, with K, where K is less than K star, you'll notice our depreciation is less than our investment. So that means that capital is breaking down. There's less capital breaking down than there is new capital being invested. So we've still got net positive capital in the economy. So as we grow towards K-star, the gap between the depreciation line and the investment curve sort of shrinks a little bit until it reaches K-star, at which the two curves are equal to each other. After K-star, we find that investment is less than depreciation. So we've got so much depreciation that we actually have more capital depreciating than we are replenishing with new investment. So here we've got actually negative growth in capital per worker. So the idea behind the Solow model of economic growth is that countries will sort of converge towards this K-star. And, the further they are away from K-star, the faster the rate of growth will be as they approach K-star. And as they get closer and closer to K-star, the growth rate will get smaller and smaller until they reach K-star, which is equilibrium. And similarly, countries with higher levels of capital per worker higher than K-star will reduce their capital per worker till they reach K-star. So that's sort of a very basic video. I hope to go a little bit more in depth in some future videos, but this should give you a very basic idea about the Solow model. Thank you so much for watching. Appreciate it.